Hello guys, welcome back to another video by Random Coder. Today we'll be talking about number 70 in the Leetcode problem set, climbing stairs. This problem is actually a pretty famous interview problem. So it reads, you are climbing a staircase and it takes n steps to reach the top. Each time you can either climb one step or two steps. And how many distinct ways can you climb to the top? And n will always be a positive integer. By n, it's referring to the parameter here. So let's look at a diagram of this problem. So I'll use blue to represent one step and then red to represent two steps. So here, there's only one possibility. For two steps, you can go up from here to here, or here and here to here, or you can do one two-step leap. For the three steps scenario, you can do 1, 2, 3, or you can do 1, 2, 3, or you can do 1, 2, 3. Okay, so I hope what you notice here is that when there's one step, there's one possibility. When there are two steps, there's two possibilities. And when there are three steps, there are three possibilities. And what you should also notice here is that after you've taken this step is actually the same possibility as this step. And after you've taken the first step here, these two steps are actually the same possibility as these two steps, or vice versa. So the recursive, so this is actually a recursive problem. And the recursive equation that you can get from here is that ways of climbing stairs n is equal to ways of climbing stairs n minus 1 plus ways of climbing stairs n minus 2. And here I drew a diagram, so it shows n when n is 5. So which calls 4, 3, and then calls 3, 2, and 2, 1, which also calls 2, 1, 1, 0, and 1, 0. So let's go code this recursive solution. This first recursive solution is actually quite simple and probably requires 3 lines of code, probably 4 lines of code. So you just return climb stairs n minus 1 plus climb stairs n minus 2. So this is the solution to the problem. However, as you can see, this solution is actually quite slow. So if I enter a large n such as 45, it should be running out of time here. So what we can do to solve this is, as you can see here, 3 gets repeated quite a lot of times. 2 also gets repeated quite a lot of times. And 1 also gets repeated, right? Also 0. So what we can do here is we can create a structure, preferably array structure, and it can store the values that are already calculated, so we don't calculate them multiple times. So here, we're actually gonna start another one. So we need an array to store this. So dp need int n plus 1. And since this method doesn't come with an array parameter, we actually need to use a helper method here. So helper method takes int n and int array. Right. So in the helper method, if n is equal to 0 or if n is equal to 1, return 1. If array n does not equal to 0, return array n, and array n after that is equal to helper n minus 1 array plus helper n minus 2 array. So that's what it stores, and what it returns should be return array n. That's what it should return. So here, in the main method, it's actually a pretty simple call. We just do helper n minus 1 and then put dp in, and then plus helper return -2 and put dp in again. So this should solve the time problem that we had before, which it does, and should also pass some of the corner cases, and this solution passes. So this is just one solution, so I'm also going to talk about another solution to this. So in this solution, we put the values that we've already calculated into an array. However, there's another more straightforward method. So as you can see, this question is actually similar to the Fibonacci question, but it's a little bit different, right? So the Fibonacci sequence is this, but this one is 1, 2, 3, 5, 8, 13. Kind of similar, but not. So when we're solving Fibonacci sequences, we can have a direct way. So we can actually make an array and then predefine the array values to be 1, and also the another array value to be 2. So once we've done that, we can just have a for loop structure. So for from 2 to 10, we can have a for loop structure, and what we can do here is basically just have the array at I equal to the previous two arrays, the sum of the previous two arrays. So that's what we can have here, and once we finish, we can just return the value at I. So that's the basic thought process of the other method. So I'm gonna code that real fast. So int array dp is equal to new int array n. So dp0 is equal to 1, dp1 is equal to 2. What you can do here is have a for loop for an I starting at 2, because we already filled the 0th and first position in the array, and I smaller than n, and then I plus plus. So dp at I is actually just equal to dp I minus 1 plus dp I minus 2. And then here you return dp I minus 1, sorry, n minus 1, because, and what should happen here is, oh, we forgot something. Still have to put this precondition in, or base condition, so it doesn't get runtimed. So I should do it. Yeah. Okay, and also here, let's try 45. Looks like it works, and yeah, it gets accepted. So let's talk about time complexity of this solution. This is actually an O of n solution, and however, it does use a little more memory storage. Another way to optimize this solution is, instead of using an array, you can just use 3 integer values. So one integer value is I minus 1, and one integer value is I minus 2, and then the other one's just a result, and you return the result. That would be a more optimal way, but we're not going to get into that today. So this is actually it for today. I hope you enjoyed the video. Make sure to like and subscribe to my channel.